On to the number work. We have prime numbers first of all. You need to be aware of what the prime numbers are. These are numbers that only have two factors, 1 and themselves. So 1 is not a prime number. It's a common mistake to put that into the list. You need to really know the first 10. Knowing the first 15 is very helpful. Knowing the first 10 is essential. Here it asks for 15. So we should be writing down 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and then we have 31, 37, 41, 43, and 47. Note in English, when we are listing numbers, we split them with commas. This list is the first 15. There's an infinite number of prime numbers, and there is no pattern to them. One special case here is number 2. Number 2 is the only even prime number because all multiples of 2 are all even numbers. And the second bit here, we're asked for which two prime numbers multiply together to make the following. So which two prime numbers multiply to make 15? Well, that's going to be 3 multiplied by 5. To make 34, that will be 2 times 17. And to make 51, 3 times 17. Square numbers come up a lot in mathematics, and they're really useful to spot if you can see them. So knowing at least the first 10, ideally the first 15, is really, really helpful because it'll help you perform a lot of your maths a lot quicker. You can make a square number by taking a number. Let's look at 1, multiplying it by itself, and then you get your square number. It's often written as 1 to the power 2. So 1 to the power 2 equals 1 times 1, which equals 1. 2 to the power 2 is equal to 2 times 2, which equals 4. And 3 to the power 2 is equal to 3 times 3, which equals 9. So here I know the method of building up the square numbers, so I can just take a number and multiply it by itself. So my first 10 square numbers, I have the first 3, 1, 4, 9. 4 4s are 16, 5 5s are 25, 6 6s 36, 7 times 7 is 49, 8 times 8 64, 9 times 9 81, 10 times 10 100. Now, when I wrote these questions, I did actually intend this to say calculate the difference between the 7th and the 3rd square numbers. So I would have been doing 49, take away 9, but I wrote it as prime numbers. So let's go back to the prime numbers and do this. The difference between the 7th and the 3rd prime numbers. Well, the 7th prime number is 17, and the 3rd prime number is 5, and the difference between those is 12. Yeah, so you might be asked to find differences between square numbers, prime numbers, non-prime numbers, and so on. So be aware that there could be different sort of questions involving a mixture even of primes and squares. Cube numbers are just an extension really of square numbers going into, you could think, 3 dimensions. So a cube number is written as 1 to the power 3 or 2 to the power 3. Or 3 to the power 3, something like that. And basically it does not mean the number multiplied by 3, it means the number multiplied by itself 3 times. So here we have 1 times 1 times 1, which equals 1. And then we have 2 cubed, which is 2 times 2 times 2, which equals 8. 3 cubed is not 3 times 3, it's 3 times 3 times 3. 3 3s are 9, 3 9s are 27. And as you can see, these numbers get very big very quickly. So 4 cubed is equal to 4 times 4 times 4, which equals 64. And 5 cubed is equal to 5 times 5 times 5, which equals 125. If you can learn the first 5 square cube numbers, that'll be really good. Just make sure you understand how they build up. They don't come into maths as often as the square numbers, but they do appear, and they're useful things to be able to work with. Next question says find the value of 10 to the power of 3. Well, you should know that 10 to the power of 3 is just 10 multiplied by itself 3 times, but there's a quick way of doing this one because it's going to be 1 with 3 zeros, or 1,000. Finally, it says state 2 numbers that are square and cube numbers. Well, these are not easy to find, but the easiest 2, and luckily this question only says find 2, is 1 and 64. The next one would be, I think, 729. But but we're not going to go there. As long as you know 1 and 64 are both square and cube, you'll be fine for anything you get certainly asked at this grade level. Finally, on to triangle numbers. Triangle numbers are difficult to remember, I think, but very easy to remember how they are created. So I'm going to do the second part of this question first, saying, how do you create the sequence of triangle numbers? Triangle numbers is something that you come across if you play pool or billiards or snooker, and you have a triangle, and you put the balls inside the triangle, and I've got a really silly one here where I have three balls or circles inside a triangle, make a triangle shape. So 3 would be a triangle number. I can have a larger triangle here, and I would have 1, 1, 2, 1, 2, 3. So that gives me the number of 6. If I wanted the next triangle number, I produce my triangle number I did before with 6, and how many do I add at the bottom here? 1 more to the next row, so the row has got 4 in there, making a triangle, and then that is 10. If I want to do 1 more, I would do everything I did before. There were 4 at the bottom before, so now I do an extra 1, so I do 5 at the bottom. 10 was the previous total. 10 plus 5 is 15, so 15 is a square number. Going backwards, you can see it goes from 5, 10, 6, 3. So if I take the bottom row off the 3, I'm just going to be left with 1. So we also say that 1 is a triangle number. And hey presto, I've actually got my first 5 triangle numbers, which was the answer to the first part of this. I say it's easier to remember how to create these than it is to actually try and memorize these. Good luck in the test. If you have any problems, please drop me a message on Google Classroom.